Students, today we will learn how to draw ray diagram for convex lens when object is placed at different distances from the lens, the convex lens. So I'm using here two letters F and 2F. F is the focal length. I explained in my previous videos that focal length is the distance between the lens and the focal point. Focal point is the point where after passing through the lens, all the incident ray after refraction, they meet at one point. That is a focal point. So that's a focal length. So I use focal length, and for example, from this is the center of the lens, and this is the point focal length. And for example, if this is 10 centimeter from here, what should be this? This should be 20 centimeter. Now the focal point is on both sides because it is convex. It is transparent on both sides. So there will be focal point on both sides. So I mark F here and 2F here. So how we draw ray diagram to find out where the image will be formed when object is placed beyond twice the focal length. So draw one line parallel to the principal axis, and once it strikes the lens, it will refract and pass through the focal point. Second thing what we'll do, from the top of the object, draw a line which passes through the center of the lens. Now you see here, these two lines, these two refracted lines, they are meeting at one point. So where these 2 points meet, image will be formed. So this image, you see the object is upright here and the image is upside down, and the image formed is on the other side of the lens. So this type of image is a real image. So what is a real image? It is upside down, it is on the other side of the lens and smaller in size. So if object is placed beyond twice the focal length, the nature of the object image is real, smaller, upside down, and smaller in size. If we quickly see all the rays we draw here, let's see from the beginning. Draw a line, passes to focal point, draw another line, where both are meeting, image is formed. So you have to follow this process for all other image formation when it is placed between focal point and twice focal point, or focal point or lens. So we'll see that also in next. So students, let's see when object is placed between focal length and twice focal length, what type of image will be formed. I explained earlier, we have to draw one line parallel to the principal axis, and when it strikes the lens, it will pass through the focal point, one incident ray and reflected ray. Second, we will draw from the top, from the center of the lens. See, where both rays are meeting, both reflected rays are meeting, image will be formed. See the image. Image is upside down, larger in size, and this image is real image. Real image is upside down and on the other side of the lens. So object is on this side, image is on the other side. So the nature of the image formed here is real, inverted means upside down, and larger in size as compared to the object when object is placed between focal point and twice the focal point. So students, let's see when the object is at F, means the object is placed at focal length, what will happen. So what we'll do, at the top of the object, draw one line parallel to the principal axis. After refraction, it will pass through the focal length. Draw another line from the top of the object passing through the center of the lens. See, after refraction, both of the refracted ray, they are not meeting at any point, so they are going parallel. So in this special case, no image will be formed. It's a special case. Students, let's see where the image will be formed if the object is placed between focal point and the lens. So let's see how we draw ray diagram. Draw one line parallel to the principal axis, passes through the focal point. Draw another line passing through the center of the lens. Now see, these two rays, they are not meeting and they are diverging. See, they are not parallel. When the object was at the focal point, the both refracted ray were parallel, but here they are going diverging away. So they are not meeting this side, but if we back produce this and back produce this, they are meeting here. So the image will be formed here. So see the difference between all other images formed by convex lens and this special case when the object is between focal point and the lens. The image is formed on the same side where the object is, and this time the image is upright and larger in size. So if the image is on the same side where the object is and it is upright, that type of image is called virtual image. And the characteristics of the images is a larger in size, upright, and formed on the same side of the object. So see, the in convex lens, if object is placed beyond focal length, real upside down image will be formed. If it is on the focal point, no image will be formed. But if it is between focal point and the lens, in virtual image, upright and on the same side where the object is formed. So thank you very much for watching this video.